All right, let's talk about a revolution. Not one that happens in the streets, but one that's happening in the cloud. We're going to dive into how the data warehouse transformed from this slow, inflexible monolith into the absolute powerhouse engine that's driving modern business. Okay, so let's get right into it. How exactly has cloud computing revolutionized data warehousing? I mean, weren't the old on-premises systems good enough for what they did?
Well, that's the core of it, really. They were becoming total bottlenecks. This quote just nails it. They were slow, inflexible, and basically built for a totally different era. They just couldn't keep up with the massive, complex, and fast-moving data that modern businesses rely on. They had to evolve or they were going to become obsolete.
So what's the fundamental architectural difference then? What did the cloud actually change under the hood to make all this possible?
The really big shift was from something called symmetric multiprocessing, or SMP, to massively parallel processing, which we call MPP. Now, in the old on-prem SMP world, you had all your processors trying to access the same single pool of storage. Just imagine a huge crowd all trying to drink from one tiny water fountain at the same time. It creates a massive bottleneck. MPP completely changes that game.
And the magic trick here is that MPP fundamentally decouples compute from storage. So instead of all those processors fighting over the same data, the cloud architecture gives each processor its own dedicated portion to work with. When a query comes in, the work is divided and conquered across all these nodes at once. That's where you get that incredible scale and speed.
That makes sense, but it also sounds incredibly complex. If your data is now spread all over the place, how does the system keep track of it all without creating a whole new set of problems? The answer is surprisingly elegant. The system uses a fixed number of storage buckets, or distributions as they're called, and that number is 60. By fixing the storage layer to 60 nodes, the system can then scale the compute power up and down independently without this massive headache of constantly reshuffling the data. So the only challenge left is how to spread that data evenly across them.
And for that, there are three main strategies. The simplest is round robin. It's literally just dealing rows out like a deck of cards to each bucket. Then you've got hash distribution, which is much smarter. You pick a key, like a customer ID, to make sure all records for that customer land on the same node. That is fantastic for speeding up queries. And finally, for small, frequently used tables, you can just replicate it. A full copy is placed on every single compute node, so it's always ready to go.
Okay, so we've got a completely new architecture. But what does this mean in the real world? What are the practical benefits for someone actually managing a data warehouse? Oh, the biggest benefit by far is going serverless. Now, this doesn't mean there are no servers. Of course there are. It just means you don't have to manage them anymore. The cloud provider handles all the patching and maintenance. And the most important part, you can pause the entire warehouse when it's not needed, which has massive cost-saving implications. You only pay for the compute power you're actively using. And this is possible precisely because compute and storage are separate. You can simply turn off the expensive compute resources, the brains of the operation, while your data just sits there safe and sound in much cheaper storage. You're only paying for storage, which is minimal in comparison. Then, when you need to run a report, you can resume the full power of the warehouse in just minutes. And when you do need that compute power, scaling up for a heavy month-end load isn't some months-long hardware project anymore. It's as simple as moving a slider. You can increase or decrease what are called compute data warehouse units, which is just a blended measure of CPU, memory, and I/O on the fly. You get to pay for only the power you need, exactly when you need it. This new architecture is fast, it's scalable, it's cost-effective, but what about getting data into the warehouse in the first place? Has that whole process evolved as well?
Absolutely. The process now is way more structured, broken into these clear layers of curation. Data first lands in a raw layer, completely untouched. From there, it moves to a clean layer, where it gets standardized and validated. Finally, that clean data is loaded into the transformed layer, which is your actual data warehouse. This makes the entire pipeline so much more resilient and way easier to debug.
But does this new model mean we're still limited to those rigid overnight batch loads? Or do we finally have some more flexible options?
Right. And while traditional batch processing is stable and predictable, it definitely comes with risks. The biggest is that rigid ETL window, where everything has to happen between midnight and 5 a.m. If a critical source file arrives late, the entire process can just fail. The cloud opens the door to much more dynamic approaches. The big change here is event-driven ingestion. Instead of waiting for a clock to strike midnight,
The process can be triggered the instant a new file is created in cloud storage. The arrival of the data is the trigger. This moves us from a nightly refresh to near real-time data availability.
And you get incredibly granular control over these triggers. You can set up pipelines to listen for events in a specific folder, for a specific file type like CSVs, or even for a very specific file name. This makes the whole data ingestion system much more intelligent, responsive, and far, far more efficient.
So let's put all these pieces together and distill it down. What are the key attributes that truly define what a modern data warehouse is today?
When you boil it all down, a modern data warehouse is really defined by these key attributes. It's elastic and scalable on demand. It supports all kinds of data, not just neat little tables. It enables all kinds of ingestion patterns, not just nightly batches. And it's all built on that foundation of a decoupled, automated architecture. It's not just an upgrade, it is a complete paradigm shift from the rigid systems of the past.
This transformation, from a rigid, slow system to a flexible, on-demand service, is really the heart of the cloud revolution. It moves the data warehouse from being a simple storage closet to being a dynamic engine for insight. And that leaves us with a final question to consider for our own projects.
If you found this explainer helpful, please do us a favor and like, share, and subscribe for more deep dives into the technologies that are shaping our world. Thanks for watching.